Hey guys, in this video I'm going to talk about the difference in differences experimental design. Also, there's a really famous paper in econometrics that used it, which was the Card and Krueger 1994 paper on minimum wage. And I also thought the paper was really interesting, or like the theme of the paper, because I only skimmed through the actual paper. But the conclusions that the paper got were really interesting, and so I thought I would make a video on it. In this video, I'm going to first talk about what pooled cross-section data is and the definitions of different data types, because pooled cross-section data is what's used in difference and differences. Then I'm going to go over how you do difference and differences, and then I'm going to talk about the Card and Krueger paper at the end. So for those who don't know already, this was a paper talking about trying to look at the effects of raising the minimum wage and how that affects unemployment. They found that there was no effect on unemployment, which was controversial to say the least. Like, that's probably still a controversial idea even today. It's kind of counterintuitive, and a lot of economists hate this paper. And so a lot of people have made rebuttals. So at the very end, I'm going to talk about that. And I'm just going to call it etc. because Card and Krueger have made rebuttals to the rebuttals since then as well. And they have a lot to say about this topic, so we'll get into all of that at the end. So let's first talk about what pooled cross-section data is exactly. So pooled cross-section data has flavors of cross-section data, obviously, and it has also flavors of time series. So cross-section data has no regards for time as a variable, so no time variable. Everyone pretty much knows what this type of data is because I think it's one of the most common data collection methods. So you just can take a survey of someone or do something to someone one time, and you don't care if they would do it differently another time. So it's what cross-section means, right? You just get a slice and you don't get more than one. Time series, it's kind of the flip side of that. So it's when you collect data at different time points and kind of like periodically. So most famously, the Dow Jones, you can have a stock here, one time point, then it goes up, then it goes down, then it goes up high, then it plunges, and then it goes like that. And so this, you're following it over time. So to combine these two, it's kind of like if you take multiple cross sections, and if certain assumptions hold, you can pool these cross sections together and kind of make a cylinder of cross sections, if you will. And so this might be 2004 data, 2005, and again, if certain assumptions hold, which I'll talk about later, you can pull these together. The benefit of doing pooled cross-section data would be that your N increases, so your sample size increases if you can do that, and that would be beneficial for lots of reasons like statistics and stuff. Okay, so difference in differences is a really simple way of doing pooled cross-section data, so let's get into that now. So difference in differences, it's literally if you just look at two groups at two different time points. So it's really simple. So the DID method is often used for experimental or pseudo-experimental data. In econometrics, you usually have, a big policy change or some kind of natural disaster or something that you can measure the effect changes between pre-event and post-event. So the two groups that we talk about are usually a control group and a treatment group, and then we have pre-treatment and post-treatment as the two time periods. So let me do a little drawing, and then I'll discuss like how you can look at it graphically and an important assumption for DID. Okay, so take this graphic as an example. So we have a control group and a treatment group, and we took a measurement in 2014 and 2015. And as you can see here, so say for example, if you have a pill/supplement and you give it only to the treatment group, and this pill supposedly you're trying to see if it helps people grow their hair faster. And so you take measurements of hair length in 2014 and 2015, but you tell both groups not to cut your hair, and you tell only the treatment group to take the pill. You can see here that the slope for T, or the treatment group, is steeper than the control group, although both groups had, some hair growth. Well, if you did the DID method correctly and all the assumptions hold, then you can reach the conclusion that the pill helped grow hair faster. So one of the assumptions, if you're going to do that, you need all the assumptions that you would need for ordinary least squares. So you need the zero conditional mean assumption, all your variables have to be exogenous, you need normality, all of that. In addition, you need need what's called the parallel trend assumption. So this would hold true only if you're assuming that the treatment and control groups would otherwise grow hair at the same rate. If for some reason your treatment group was growing hair faster for another reason, then the pill wouldn't necessarily have made people's hair grow faster. So you're assuming basically that their hair would have, if I can draw a parallel line, it would have been, no, it looks like I can't. You're assuming that the hair would have grown, let me try one more time. It's so hard on this, like that. Okay. You're assuming that the treatment group would have grown at a rate similar to the control group, and this extra additional growth is therefore caused by the pill. And so how do you prove that there's growing at the same rate? There are two ways that I know of. So you can make sure to take measurements before the two time periods that you tested to show that the rates are both stable and that the treatment and control groups are the same rate. You can also get a second control group and see that they also are going at a parallel rate. It was easier for me to draw the line that time for some reason. And so if you have two control groups and a treatment group, then you can say, yeah, they were growing at the same rates. I have two control groups. You can compare multiple groups or compare more times, basically, and that will cover your parallel trend assumption. So now let's see the DID method written out as, the equation or the model form, and you'll see one of the reasons why it's like a nice and pretty model. So you have your dependent variable, so that could be hair length, it could be log wage, it could be anything, and then the model would be B0, your intercept, plus B1, so treatment, plus B2 post, and these are treatment and post are dummy variables, and then you have an interaction term B3, treat, post, plus your errors. So this is the variable or the estimate of interest. You want to see, is the B3 estimator non-zero? And if so, your slopes are going to be different and you're going to have that extra slope for the treatment, hopefully. And then if you do, is it significant? So that's what you want to see for this model. And again, one of the nice things about it, and the reason it's called difference in differences, is that you can calculate this manually by hand if you know the sample averages. There are two ways of calculating it. You basically take the difference between pre and post and treatment and control, and then you take the difference of those two. So let me write it out and then I'll talk about it. Okay, so this is what it would look like written out. So you take a difference here and you take a difference there, and then you take the difference of the two differences. So that's why it's called difference in differences. And so it's a really simple, formula, but it's very effective, I think, as a modeling tool. So now let's go to the third and final part of this video, which is to discuss an application of this method, which was done in the 1994 Card and Krueger paper. Okay, so this is a picture of Card and Krueger. I don't know which one's which. Actually, I think this is Card. I think this is Krueger, but don't quote me on that. And this is a screenshot of the title of the paper that we're going to be talking about. So this is the 1994 paper. It's actually freely available online. I think David Card is a professor at Berkeley, and he posted the link to his paper. So I'll put the link below, but I think if you just Google it, you'll see it as the first link. There are PDFs of it available online. So let me just talk about what this paper was talking about before we get into the statistics. They basically were trying to look at the effect of raising the state level minimum wage. So this is a policy change, like pseudo experiment, and they wanted to look at the effect of it that it had when New Jersey raised the minimum wage. I think it was in 1992 the minimum wage was raised from $4.25 to $5.05. The way they looked at how this was affecting people was that they did survey data before the 1992, I don't remember what month it was, but let's say it was October 1992 that the law was passed. So they did a survey a couple months before the minimum wage was raised and a couple months after. And they surveyed fast food restaurants and they asked people about the prices. They asked how many workers do you have. They measured whether a store was even still open before and after. They called and they asked a lot of people, and they said that they had, because sometimes you might call someone previously and then the second time you try to follow up with them you can't, but I think they had like a 92 or something or more % successful rate of getting the same people to answer their surveys before and after. And all this data is in the paper that they talk about. And actually, I'm reading my notes. It says there was a 7-month difference. So there was a 7 months separation between the two calls. I should have gotten a picture for this. I don't know how to draw. That's a bad drawing. But they called basically restaurants in eastern Pennsylvania, which that's my drawing of Pennsylvania, and this is eastern Pennsylvania, and New Jersey. So they basically were saying or making the argument that eastern Pennsylvania and New Jersey are going to have similar economies, and so eastern Pennsylvania was acting as like the control group for this natural experiment, and New Jersey was the treatment group. And the previous time that they picked was before the law was enacted because they knew when it was going to be enacted, and the post was a couple months after the law was enacted. The paper discussed this as well. The law was passed, I think, in 1990, or like a few years before the recession was taking place. At the national level, there was a recession, and the state Congress of New Jersey almost tried to block the minimum wage raise as a result because they said it would be bad for business, but it still got passed. And so they collected data. At least when I was thinking minimum wage fast food restaurant workers, I was thinking, okay, they asked a bunch of McDonald's restaurants, but it actually says what restaurants they picked, and actually McDonald's wasn't in there, but I think Wendy's was one of them. Burger King was one, I think, and they asked 4 different restaurants. Okay, so as you can see, it has the months here. It was February and November. Okay, whatever. So as you can see here, this is a little table that you can do for difference and differences, and this is the difference and difference B3 estimate in my model. So obviously on one of the things that they asked was about employment, and so I think these were measures of full-time employment, and they actually found that there was an increase in employment. Basically, what they argued in this paper was that the minimum wage raise in New Jersey did not cause a decrease in full-time employment. And they're not arguing that it increases employment. They're basically saying that it doesn't have a significant effect. Because if you have, an effect that's contrary to what you're thinking of, that's kind of like counterintuitive, and you might think that there's a problem with your statistical analysis or your experimental design. But I think whether this was significant or not, I think they just made the argument basically that it has no significant effect on unemployment. Now, they also looked at, does it affect price? And I think that they did find that some restaurants in New Jersey did increase their prices, but that was not even consistent within New Jersey. So I think southern New Jersey had some price increases, but North New Jersey didn't. And that's basically what the paper was saying. Now, a lot of people have criticized this paper. I think when I heard about this paper in class, one of the things my graduate student who told me about it argued was that it failed the parallel trend assumption. He made the argument that the recession hit Pennsylvania worse than it hit New Jersey, and that's why you didn't see that New Jersey's unemployment fell worse than Pennsylvania, because Pennsylvania's unemployment was just falling at a higher rate already. Now, I think I skimmed through the paper, and they did measure, I think I remember seeing that they looked at teenage unemployment rates prior to the 2 measurements that they got. So if they did do that, that would be a measure of trending rates. Now, I don't remember if that's 100% true or not, but I think they did do that. To me, the more obvious mistake is that they obviously took measurements really close to when the law was enacted. So they literally took it just a few months prior and just a few months afterwards. So for me, that's obviously a red flag because, well, if you raise the minimum wage, you're not going to get fired. Maybe you're not going to get fired the day the minimum wage raises, or even 5 weeks after the minimum wage is raised, but you might see that difference, you might get fired a year later when they look at their revenues and see that they can't employ as many people. A lot of people have made rebuttals to this paper and said they've made that critique, and they've made other critiques about the experimental design of it. A lot of people have said that if it doesn't affect unemployment, it affects job growth rate. And I saw that a lot when I was skimming through like what people had to say about it, that if you do increase minimum wage or just wage in general, then that will decrease job rate. And they also actually looked at, I forgot to mention in this paper, they also looked at non-minimum wage workers and how raising the minimum wage affected people who already were working above the minimum wage. And I think that they said that those people's wages didn't increase. So if you increase the minimum wage, that didn't mean your wage was going to increase, regardless of what your their starting wage was if it was above minimum. But anyway, going back to this, I think it's pretty well documented that increasing minimum wage does decrease job growth rate. Now, it's not a one-for-one, it's not proportional. I think I read somewhere that if you increase by 30% the minimum wage, then that only decreases like 0.5% the job growth rate or something like that. But maybe that was just in one specific state. It probably depends. But okay, so that's one argument. Now, Card and Krueger have gone back and made a lot of rebuttals since 1994, defending their results and also like finding more data about unemployment and the effect of raising minimum wages at the federal level or state level. They in particular, I don't remember what paper it was, but I'll try to find it and maybe put the link in the description box below if it's available. But I read briefly that they did a meta-analysis. That's basically when you take a lot of people's study results and then you actually do statistics on the statistics that were done in other studies. So you take the results of a bunch of studies and analyze those, and they said that basically the reason people think that there's unemployment increase when you increase minimum wage is because of publication bias. So they said that papers that found no significant effect on unemployment were less likely to get published because there's just a publication bias in general across science that says, okay, if you're going to get published, you need to have significant t-statistics and p-values, and if you don't, you're not going to get published because it seems like your study didn't really discover anything. But I haven't actually read that paper, so I don't know how they could come up with that assumption, but that's what their meta-analysis allegedly says. So I'll put as much information about it below as I can. Actually, I got this table also, by the way, from Wikipedia, so I'll put the Wikipedia page link for difference and differences below as well. And if anyone is interested in this econometrics question about the effect of minimum wage, I'll try to put some resources in the box below as well.